Hi class, welcome to week 3. This week we're going to get into conditionals and program flow. Now, for a computer programmer, something that you need to know is that deep down under the hood, take away all the complexity and marvels of modern computers and software. What you really have at the very bottom is a bunch of switches. Yes, no, on, off, that kind of thing going on. And a program simply follows conditions. If this variable, if this value equals this, do this instead. If it doesn't equal this, do this instead. So there's this concept of flow, right? And oftentimes we kind of represent that as like a railroad, right? Because railroads use switches. And that's the reason I kind of pulled this graphic up right here where we got this busy train yard with all these different tracks and switches to move along these different paths, because that's a nice way of visualizing what actually takes place in a program. You're going to have the user input something or click on something, or some data value is going to come along, and you're going to send your program down a different path depending on the condition that you want to achieve, or the condition that's apparent or present in the software. Just to kind of drive that home, this idea that really computers are nothing but a bunch of switches. I mean, here's a transistor, right? The most basic form of a switch in electronics. And if you just looking at this, right, it still has that visual representation of a switch. We have current flows across this, and at a certain point and level, it's going to send current down another path. So that's just at the very, very basics. I mean, even beyond, lower than programming itself. I mean, just the physical hardware, the electrical engineering of it. It's still just a switch. Now, let's go back up here into the model type form here of a flow diagram, where we're representing in a way here with graphics what a program, how it flows through a conditional. So the conditionals have a yes, no, true, false type of operation here, right? Again, that switch idea, where we've got let's say we've got a variable and it's loaded with an integer value, and this conditional will test that, and if the condition is true, for instance, let's say the value, we're looking for values that are greater than 10, then anything greater than 10 could be sent down this other path for true, and values that are less than 10 will continue on and some other code will execute. Now, you find this stuff everywhere in programming, but let's go with like a common example of let's say you're writing some software and it needs to validate a username and password against some database that's out there. Well, the user's going to log in, you'd take their login information, and then you'd have to go off, have a routine that takes those two pieces of credentials and checks them. Then, once that check comes back, saying whether or not they're valid, your program could say, okay, if the user failed to log in, then I want this code to run, which is essentially sending them back to the login screen, maybe with some error information and informing them that their password or their combination didn't work. But if their credentials are true, meaning that they've logged in successfully, then you bring up the rest of the program, so you'd go down a different path. Okay. In Python, what we have as our primary conditional tool is our if statement. And ifs come with, we have if and else, and we have if and elif. And these are different ways of controlling the logic of our condition. So for today's lecture, what I'm going to do is I am going to bring up idle, which is the Python GUI. Alright, and let's go ahead. Let's see, tuck this over here, and let's say file new, and we'll tuck that over there. Okay, so I'm going to use idle here, and let's just write some quick little programs to demonstrate conditional flow control. For my script, you will notice that when I'm doing this, to save time, I'm not going to go PEP 8 compliant here. When that's for submitting homework and making sure everything is formatted properly. Now, if I was going to turn the stuff in, I would go back, clean up my code, make sure that I was following all the coding guidelines. But for our demonstration purposes, I don't want to get into that just now. Let's just start with a real simple program. So let's create a variable called foo, and then I'm going to assign that variable a value of 1. Now let's go ahead and create our condition. So we'll start with if, and we'll say if foo equals 1, semicolon. Now comes the indent. So indenting is how we tell Python that this block of code belongs in this code section, part of our condition. Lutz goes over in great detail in the text of chapter 10 about the different ways you indent and how that's nice. It's really one of the, I think, more beautiful things about coding in Python is you don't have to have all the the brackets and parentheses and all that in here. And this is what makes Python real clean to write. So, but the important thing is making sure I have this tab indent space here. Now, nice about working in idle is it goes ahead and does that for me. Saves me having to hit the tab. Okay, so what we said here is if foo equals 1, now we need to tell it to do something if it equals 1. So we'll say print true. Alright, notice that I'm using the Boolean here, right? So I've written this with a capital T, so when Python evaluates the code, it will see, oh, he wrote capital T true. That means that this is the Boolean true. Alright, I'm now going to go File, Save, and let's just call this foo, and run it. Alright, so now we executed over here and it ran. Actually, we'll just bring this over a little bit more, give ourselves a little more room here. There we go. Okay, so the variable foo was assigned the value of 1. 1 is also a true value if you think about it, right? Because what is a Boolean? It's either 0 or 1. 0 is false, 1 is true. Then we had our conditional statement, if foo equals 1, then go do this. But what if I changed foo to 0, or essentially false? Okay, this time let's go ahead and run it again. Now when I'm using idle, it's kind of telling, hey, do you want to save this? And I'll just go ahead and say yes, and then it'll automatically execute. But notice, look at this, nothing showed up, right? Because there is no other alternative. Foo was 0, therefore this conditional returns a false, right? Foo doesn't equal 1 anymore. Therefore it just continued on and did not execute any of the code that was indented after the if. Well, we can use else to change that behavior and print false. Now there's no way out here, right? It's going to either be true and print false, or else it's going to print false. So this time, to save time, you can use your hotkey. So I'm going to hold down Control, press S, and that automatically saves it. And I'm going to hit the F5 key just to go ahead and execute. And there we go. All right, so the program goes through, doesn't equal 1, therefore it skips that, down goes to else, and prints false. We can change this up a little bit. Let's put another type of situation here. What if we had a value of 15 here? Now, 15 isn't 1, right? So if I save that, hit F5, I'm going to get false, right? Because it's not 1. But there's another thing we could do here. We could say elif. Now in other programming languages, you'll typically see like else if, as written in there. So this is sort of a version of combination of if and else combined. So you'll see it first executes this and evaluates this condition, and if that's false, it continues to the next condition, which is marked by an elif, sort of like an else if type thing here. So we'll say if foo is greater than 10 and foo is less than less than or equal to 20. And we'll put these values here. Okay, so now what should happen, right, is foo gets loaded with a value of 15. This condition returns false, but now is foo greater than 10? Yes. And is foo less than or equal to 20? It is, so we would expect it. The program should then print this statement. Alright, Control S, F5, and there we go. So this time it went down this path. Right? So if you imagine that, those train tracks again, right? Nope, not going to Chicago. I want to go to New York. So then it diverts down here. If we didn't know where we were going, it could say send us to Orlando, Florida, if that's what we had for our else statement. So we can have a more complex logic statement here, and then if you notice what I'm doing here is I'm doing a compound conditional, where this conditional has two parts. Make sure this is true and make sure this is true, and if both are true, then do this. Now, for our conditional statements, we don't have to just use equal than or greater than or less than, those kinds of things. We can do something sort of related to what we were doing last week, where we were working with operators. What if we wanted to find out if foo was an even or odd number? Well, we can use our modulus for that. So I'm going to change the condition to say foo modulus 2, right? Because anything divided by 2, if it's an odd number, will return a value of 1. Now let's think computer programming again. A value 1 is essentially true, right? I mean, that's what our booleans are. They're just dressed up versions of 1s and 0s. So a value of 1 being returned here will tell me that this is an odd number. And let's dress it up like this. We'll use some string formatting. And now with even and odd, there's only two choices, so in this case just another else will satisfy the rest of our logic. Okay, so now we're going to pass this through. It's either going to be return a value of remainder of 0, which would be false, and therefore false will pass down and get caught by our else statement. If it is an odd number, it will return a remainder of 1, which is going to be evaluated true, and then print this. So I'm going to hit Control S, F5, and there we go. So when it goes to print, we're going to do some substitution here, because we've got our substitution markers. And I like this example too, because you can see kind of some things you have to keep in mind. Up here, inside the conditional, the percent symbol is acting as my modulus operator. But down here, in my print formatting, it's more acting more like a delimiter of sorts, right? It's saying, hey Python, here's my string, and then coming after this is going to be my series of replacements for those substitutions. Okay, that concludes this lecture.